Mr. Abhishek is from Smart Village Education Private Limited Company from Hyderabad. We'll be dealing with the FERAS topic and also we'll be dealing with NLP and practical courses, hands-on training on uh, NLP topic. So I request Abhishek sir to start with the session.
Sure. Thank you, ma'am. Okay. So, good afternoon, everyone. This is Abhishek, guys. This is Abhishek, working as an AI developer. I basically work in developments and I also do trainings. So currently, I'm working on building image recognitions and face recognition based systems, and also building few uh, chatbots systems. Okay, and also I'm involved into data analytics and auto ML based uh, projects. Okay, and I'm in this field for about past 4 years, and yeah. So this is a simple brief introduction.
Sorry to interrupt, sir, but your voice is not audible, not very much clear. Like it's very low.
Just a second. Yeah, am I audible right now? Is my voice audible?
Yes, sir.
Perfect. Perfect. Yeah. So, okay. So this is Abhishek. I'm working as an AI developer. I basically work on building image recognition and face recognition systems right now, and also building some chatbots, intelligent chatbots, and data analytics based systems, auto ML based systems. Yeah. So yes. So now let us start our session today. So let me share my screen. I hope you can see my screen, right? Right? Perfect. Yes. Are you able to see my screen?
Yes, it's visible.
Perfect. So now in this afternoon session, already morning session, I guess Mohan sir have taken you brief about how actually a Google search engine optimization works with the help of the TF-IDF factor calculated for the all for particular words and the sentences in a corpus and in the documents, right? And based on the particular factor, whatever we get and whatever weight according to the how much weight your these particular pages are assigned, and based on that you'll be getting the rank of the uh, pages in the Google search when you're working with Google search, right? This is how generally it works. Now, now in this session, in our next coming 2 hours or 2.5 hours, whatever, we'll be dealing with building a sentiment analysis system with Python programming hands-on, right? We'll be completely hands-on. So end of theory, we'll be completely dealing with hands-on, and we'll be working with hands-on, and we'll be starting from scratch, like taking a sample data set, pre-processing it, and building some kind of intelligent system to analyze the sentiment. First, let us talk me about this particular sentiment analysis based system. Okay, first let us talk about this. What is sentiment analysis? What exactly is sentiment analysis? Let us understand. Generally, guys, when you are generally when you speak about people, we speak in various tones, right? And we also text in various tones, and we actually give reviews in various tones in a lot of platforms and various sites. Actually, you can say. Now, for example, if I go to a website, or if I go to some kind of platform, or if I go to my some kind of feedback system, or somewhere I go and just say, "Wow, this is wonderful." What do I mean by this? What is my sentiment here? What is my sentiment here? I'm happy, right? I'm excited. I'm satisfied. True. Yes. For example, if my review is like this, not good, or if I say this is bad, or if I say worst, when I say in this kinds in this way, or when I speak, or when I actually write somewhere the review, or when I go somewhere and speak this kind of words, it means that I'm unsatisfied. right? I am uh, I'm sad, I'm angry, in that way, right? So whenever you see some kind of text, especially whenever you're seeing some kind of text, you can actually analyze the sentiment based on the words and based on the way you're speaking. Sometimes it might be sarcasm also. Okay, there may be a sarcasm also. Okay, sarcastic kinds of words also sometimes. Yes. So depending upon the way you speak and the way you write something or the way you text something, right? You'll be deciding the sentiment. That is what sentiment analysis is. Let me explain you what exactly and where exactly you can use the sentiment analysis. Let me take a practical example, a real-time example you can work on or companies are working on right now. Okay. Let us consider you have called to Amazon customer care or Flipkart customer care or some ex-customer care, Airtel customer care. You have called. You have called to some customer care for a query. Okay, you have a query or you have some complaint. You call them. You'll ask. You'll actually raise your complaint and you'll try to solve your complaint and you'll try to resolve the issue. Okay, at final you have resolved your issue. After resolving your issue and everything is done with the customer care executive, at the last, they'll say like this: Sir, thank you for your time. I'll be transfer me call to the feedback executive of feedback solution system. Please give my valuable feedback or please give your valuable feedback regarding the call. Will you stay for the call? Will you stay until you give the feedback? How many of you stay until giving the feedback? I don't stay max 5 minutes. I just cut the call for sure, to be frank. Yes, we generally cut the call or we just hang up, right? Do you agree with me or not? Yes, of course. Of course, right? Of course. So, so we generally, when you speak about people, people will not be might not be interested uh, in giving a feedback manually, or you might not be having some time. Of course, it is not your problem. It is not my problem. It is not someone's problem to wait and give a feedback. You might not be interested, or you might not be what do you call you might not be in a position to give a feedback. Also, you might be having some other works. It is an acceptable problem only. You might not be in a position. So in that case, how can we solve the problem? Ultimately, we need feedback. We want to know how the customers are satisfied or not, or we want to know whether the customers are perfect or not, or whether the customers we have solved the customer query or not. We want to know that one. How can we solve this? How can we do this? Then here comes your sentiment analysis system. Instead of actually making my so and so person to give a feedback, I'll make my AI system to give a feedback, to get the feedback from that. So what I will do is I will record the entire call. Of course, the call recording is already happening. I'll record the entire call. What I will do, I'll give this call recording enter to my AI system, to my AI system. Whenever I give this entire call recording to my AI system, based on what my customer is speaking, but at the end, guys, almost for sure, I can guess, I guess at the end, for sure, you'll say thank you for your query, or thank you for your like what do you call, thank you, my issue is resolved, or so and so. Like, you'll thank them, or you'll be talking in a pleasing way, even though if you talk in a high pitch in the starting time when your issue is resolved, right? You'll just thank them. So here, based on the entire conversation made between my customer care executive and your what do you call, the customer, you can actually classify and identify how is your customer satisfied, instead of transferring my call to my feedback system. Getting my point? One of the important use case of sentiment analysis. One of the important use case of sentiment analysis, feedback. Or you see in Google reviews also, a lot of people will be keeping the reviews, or a lot of people will be giving the reviews, or else in any sessions also, like after the session also, you'll be giving some feedback, right? And in any session, if you attend to any session also, you'll be giving some feedbacks. So what we can do, we can take all those feedback and give to my AI system and tell what is my sentiment there and how many people are really satisfied and how many people are not really satisfied. That is what exactly a sentiment analysis is, right? Perfect. So in that way, with the help of your sentiment analysis, we can classify, we can identify a feedback. Okay. Now let us try to build a sentiment analysis system. And in this, for building the sentiment analysis system, we'll try to use a restaurant reviews. Okay, we have a data set of various restaurant reviews, a classified restaurant reviews. We'll be using that particular restaurant reviews to identify, to classify a positive sentiment or a negative sentiment, whether it's really satisfied or not satisfied. All those things we'll try to classify. Before classifying, let me explain you how this particular this sentiment analysis, or how this particular, when you're doing any NLP based project or when you're working with text based project, how it works, how it, the flow of the text based project will be. Okay, perfect. So coming to the initial step, you'll start working with text documents, right? You'll be working with some kind of text documents. You'll be creating some kind of text documents. You'll be having the text documents with you. You'll be having a lot of documents. It's nothing but your data, right? And of course, whatever data you're having right now, your data might not be perfect, exact what you require for end applying a model, or for applying some kind of any kind of analysis or doing some kind of interpretation from the data. So you'll do some text pre-processing, because at end of the day you'll be getting a raw text, right? From the from, it might be from your client, or it might be from your management, or it might be from somewhere you got your data, or it might be from your online, like you might find some online data also. Somewhere you got your data. It's a raw data. It's a raw data, right? So in that case, you have to apply some text pre-processing. Text pre-processing, we also call it as text mining. Text mining. What exactly do you think is mining? What exactly the meaning of mining is? What exactly is mining? General meaning of mining. General meaning of mining. What do you think? Okay, to extract. Okay. Next, any other? Okay. Generally, we generally use like generally we basically uh, say mines, right? Mine. We generally say mines, and we say mining, right? Gold mines, or we just say we're just mining the ground and all those things. So what they will do, they'll mine the ground and they'll extract the important minerals and important elements from the ground, right? In the same way, when you speak about text mining is nothing but removing the unwanted information, removing some kind of unwanted information from the text, removing unwanted information based on your use case. In our case, our use case is sentiment analysis. In your previous, when Mohan so taught you, it is Google search engine optimization, right? Search engine for finding out the best page for your other site. So removing unwanted text from your data, whatever you're having, and mining or getting the actual text from your data is nothing but text mining. Okay, so mining, we'll be doing a lot of techniques there. You'll not use one single technique. You'll be having multiple techniques in text mining, where you'll be removing unwanted text, and you'll be actually taking wanted text itself. You'll be working with wanted text itself. That is called as basically, that is generally termed as text mining. Okay, text mining. Okay, so text pre-processing or text mining is nothing but pre-processing your text such that you can get your wanted data and removing some unwanted information from that, right? And then what you'll do some exploratory data analysis. What exactly meant by exploratory data analysis? Analyzing your data, because ultimately when you're trying to build an algorithm, or when you're trying to build a sentiment analysis system, or any kind of system you want to build with the help of text, you have to analyze the text. You should understand what is the present in the text, what kind of information you have in the text. You have to analyze that one. You'll do some text processing and explore data analysis, EDA. After doing some EDA and all those things, then you'll do the feature engineering. Of course, based on the analysis, based on the information from the based on the interpretation, you will do some feature engineering. In feature engineering, what you'll do, you'll try to create a vector, or you'll try to create a important features, vector of features, and remove some unwanted features which are not needed for your further modeling or further building a machine learning model or deep learning model, right? So you'll be representing your text in the form of a feature representation. Okay, in the form of like just now last before lunch, you have explored about TF-IDF, right? Term frequency, inverse document frequency, and we discussed about bag of words model also. So in that particular way, you will be representing your text in the form of a vectored format, a vectorized format. Okay, once you represent your text in the form of vectorized
Sorry
format,
to disturb, Abhishek sir,
yeah, please.
but I think PPT is not in that mode. Okay, it is not in presentation mode, slideshow mode.
Is it in this is in presentation mode itself? Like, are you facing any problem? Yeah, I guess now it is okay. Now is it okay? Now it is
Now it's
visible.
okay. Now
Okay.
it's okay, sir.
Problem with this
Hmm.
Google. Okay, problem. So yeah, so we'll be doing text pre-processing or we'll do text mining or we'll do with text pre-processing. After text pre-processing, I told you that we'll be implementing. So text pre-processing is nothing but removing some unwanted information, removing some data, some junk data, or some kind of raw data which is not needed for us. Okay, we'll discuss what are the different things we do in this text pre-processing in our next step. And then after once the data is cleaned, means more clearly we can say it's text mining or text cleaning. We'll clean your data completely here. After that, we'll be applying some EDA process. We'll be exploring your data. We'll be understanding your data here. We'll understand what kind of data is I am. Like you'll do some analysis here. Count, it might be count analysis, or you can apply some kind of statistical analysis, what different kinds of analysis, or you can apply some visualization techniques here to analyze your text. Once you're done with exploratory analysis, like once you're done with EDA, then we can represent your data in the form of a text representation, in the form of feature representation. Basically, guys, when you are having your text, it will be in the form of text string format, right? You cannot apply a string directly to a model, to a machine learning model or ML model or a deep learning model, because ultimately machine learning model or deep learning model is completely a mathematical algorithms. So for that kind of algorithms, you cannot apply simple text kind of thing here. So you should do some feature engineering. You should apply some vectorization concept. So you have to represent your data in the form of vectorized format. So I guess you have learned about bag of words and TF-IDF in the last session, right? You learned about what is TF-IDF, how your word is converted into a score kind of format, and how bag of words converts into term frequency, right? So in that way, you'll be representing your features in the form of a entire vector. Once you have done representing your data in the form of features, then we'll apply your modeling. We'll start doing your modeling. In modeling, either you can apply a neural network model, or you can apply a deep learning model, or you can apply a machine learning model, which is flexible for you based on the model performance. And finally, you can evaluate your model and deploy your final end model to your production level. These are a general flow of an NLP project, or when you're working with any kind of text-based project, these are works. So you'll be having a text documents from starting with pre-processing, parsing, feature representation, mining, modeling, and finally deployment. So now we'll be doing this each and every step by step, with a simple sentiment analysis system. Perfect. Yeah. So any doubts in this right now? Clear? Clear with this? Am I clear? Up to now, am I clear? Okay, perfect. So now what we'll do is we'll take a sample data set first. We'll take a sample data set and start implementing these all sentiment analysis. Okay. So in order to work with our data set, you can just go to this particular URL. You have your data set in this particular URL. The URL is tinyurl.com/data-nlp. You can just go to this particular open source URL, guys, for working with sentiment analysis for this particular data set. Just go to this particular URL. We'll discuss about the business case and the use case. Okay. I'll be sending this particular URL in the chat session. You can just find the URL in the chat session. So this is a data set we are working on, right? So okay. So in this data set, if you observe here carefully, this is a data set of restaurant reviews. Okay, this is a data set of various restaurant reviews you have. In this, you have mainly two columns. You can see one is review. Here you have all the reviews of restaurants, and the sentiment, that is liked, whether the customer is satisfied or not. The label for the particular review, I can say the label for the review. Okay. So you can see the first review. The first review says that, wow, loved this place. And the label is one. One means positive, right? And the second review says the crust is not good. And the label is negative, 0. Not tasty, negative. Yeah, some like this will be having number of reviews here, approximately of some 1,000 reviews here. Now what I will do here is, I'll be using this data set, this particular data set. And by using this data set, I'll be building an AI system which can actually analyze a sentiment whenever I give a new text. So my end goal in this project is to use this particular data set and build a ML model or a deep learning model such that whenever a new customer gives a review, it should immediately identify whether he's satisfied or not and perform some action. That's my end goal. This is my end use case, end business use case. So based on the previous reviews, whatever I got, and based on the labels here, I have to build a model which can analyze the sentiment, and based on that, I can go for future integrating to my system. Okay. So you can just download this particular data set in your local systems. Okay. You can download this particular data set in your local system somewhere. After downloading this particular data set, let us start building this particular algorithm, and let us start building this particular text model with the help of Google Colab. Okay, Google Colab. Basically, you can actually do in your local environment itself, but you have to set up everything. So instead of setting everything to make it easy go, you can use Google Colab. So you can just go to collab.google.com, collab.research.google.com. Let me explain you, the people who don't know what is Google Colab. Google Colab is nothing but it's a platform. It's a platform where you can actually use, or you can create notebooks where you can create your environments, Python environments, and you can start executing your code. The advantage of Google Colab, guys, here, Google Colab has all pre-built libraries, all the data science libraries what you're using right now, all the machine learning libraries, or all the AI libraries, whatever you're using in Python, all the libraries are pre-installed in Google Colab. So no need to set up everything from scratch. Everything is installed in Google Colab. You can just go to Google Colab, create a new environment, create a new notebook, and start using it. And one more advantage of Google Colab is, see, one advantage is you'll be having the predefined all the libraries. And one more advantage you have in Google Colab is you will be able to use GPU environment also. For example, if you're training a very high neural network model, or you're building a very huge image recognition model, in that case, you have to use a GPU based system. CPU might not be enough for you. So in that case, Google Colab provides you GPU capability also. So to use this particular Google Colab platform, you can just go to collab.research.google.com, or you can just search for Google Colab over the internet and you can find it. Let me give the link here. Okay, you can just go to this particular link, collab.research.google.com. Okay. Right. Once you go to the collab.google.research.com, you'll be in this particular page, right? So you can do along with me if possible, if you are able to follow, and if you are able to do, you can do along with me. So once you go to collab.research.google.com, here you can find in this page, you can find the option called as new notebook. So new notebook means it creates a new Jupyter notebook over the cloud. Okay, so you can use all the libraries and all the pre-installed systems in this particular new notebook. So you can just open the new notebook here, right? Empty notebook will be created for you. Right? So you can see a empty notebook is created for you. Empty notebook is created for you for building your systems and whatever you want. Okay. Perfect. So you are able to follow this one. Clear? Any doubts here? Up to here? Are you able to follow? Clear? Any specific doubt? Clear, everyone, up to now? Yeah, perfect. So now, once you are in Google Colab, once you are in Google Colab environment, you can start importing your data set and start working with the data set. So as I already told you, here you'll be having the steps for implementing this particular text pre-processing and all the stuff of building an NLP model, a sentiment analysis system. So first, we already have the text documents here. So you can see this documents here, and I've downloaded here. I've downloaded this particular document in my local system. Okay. Now in my local system, I have my restaurant reviews .tsv file actually. If you observe here, guys, you can see that the file is in the form of .tsv format. Can anyone guess what is .tsv? What exactly is .tsv? What is .tsv? Anyone? What exactly is .tsv? Any idea? Any idea, guys? What is .tsv? Okay. .tsv stands for app separated values. Okay. Basically, when you speak about data sets, when you're working with any kind of data sets, generally you can see CSV formats. Okay. Generally, when you're working with any kind of data sets, you can see comma separated values. But the main reason why we are going for tab separated values, I'll just show you what happens, what we have and how tab separated values looks. So this is my restaurant.csv file, guys. This is my file actually. You can see here, restaurant.csv file. If I open this restaurant.csv file in some kind of notepad or something, if I open in Sublime or if I open in Notepad, okay, this is how restaurant, this is my reviews look. This is how our reviews look. So you can see that the data is separated by tab here. You can see that your data is separated by a tab space. That is the reason this particular file is, or this particular the extension is called as tab separated values. Okay, you can see here. Generally, we can go with comma. We can go with comma separated values. Generally, when you're working with any kind of like machine learning data sets and structured data sets, you'll be working with CSV files itself, comma separated values. But why we are going for tab separated values? Because there's a chance that your reviews might contain comma in the middle. You can see here, right? You have a comma in your reviews. You can see some commas in your reviews, right? Whenever I give a review, you can also have a comma, right? You might have a comma in your reviews, right? So whenever you have a comma in your reviews, when you're parsing this particular data set, your parser will be confused whether I have to go for comma or should I go for tab, right? So that is the reason, especially when you're working with text kind of data, we'll be using tab separated values compared with comma separated values. Okay, so tab separated values means a data which is separated by tab. So whatever data set you have downloaded, you can just load that particular data set into the Google Colab. Okay, you can just load into the Google Colab. So let us see how to load your data set into the Google Colab. Okay, so if you want to load your data set into the Google Colab, you can start like this. Like if you want to import your files, you can start like this. You can simply say from, you can say google.colab. Okay, because right now we're using Google Colab's library, import files. Because ultimately I want to load my files here, right? Ultimately I want to load my files. So from google.colab, import files is the first step. Okay. This is the first step. This is a step we are doing for actually loading our restaurant reviews file into the Google Colab environment. Okay. So once your environment is created, you can just run this particular code first. Okay. Now, once you have imported this particular files library from Google.Colab, once you've imported your files, then you can create a variable here called as upload something. You can create a variable called as uploaded something. You can create any variable here is equal to. In files, guys, you have a function called as upload. Okay. In your files, you have a function called .upload function. By using this particular upload function, you can actually upload your files in the Google environment, in the Google Colab environment. Okay. So just files.upload. If you use files.upload, you can upload your files in the Google Colab environment. So you can just run this code. The moment you run this code, you'll be getting an option here. You can see here, you got an option to actually upload your file here. So in this case, what you can do is you can just say choose file. and you can choose your restaurant reviews file, restaurant reviews.tsv file. Click on open. Once you have clicked on open, it will automatically import that particular restaurant reviews file into the file systems. So you can see here. Okay. So now if you look at your folders, okay, here in the uh, left side, okay, in the left side, you can observe this particular folder system. If you open this, you can see that restaurant reviews underscore reviews restaurant underscore reviews.tsv file is imported. So what you've done here, we have used Google Colab library and we have imported our file into the Google Colab. Now let us start reading our file. Okay, for reading our file, we'll be using a library called as pandas. Okay, we'll be using a library called as pandas. The people who don't know pandas is nothing but it is just a data analytics tool. It's a data analytics library of Python for implementing some kind of data manipulations and data analytics and some kind of statistical functions and all those things. Right? So we'll just import this one right now. So let's say import pandas as PD. I'm just importing the pandas as PD. Okay. After importing your pandas library as PD, whatever, now you can read your file, right? You can read your file. Right now, whatever file I've uploaded, guys, that particular file is present in a variable called as uploaded. You can see, you can run this uploaded. In this uploaded, you can see that your file is present here. Your entire data is present here, right? So in this case, what I can do here is, in order to load my file, actually, in order to load my file into the proper format, I can use a library called as IO. IO stands for input output. Okay. Here IO stands for input output. So with the help of this IO, I can actually read my file. So let's say import IO. Then what we can do here is, we can first convert our data into the proper bytes format. Okay. So I can simply say IO dot bytes IO. I can use this particular bytes IO. And here I have to pass my uploaded. And in that, I have to pass my file name. The file name is restaurant.csv. So let me explain you what I've done here. First, I have imported a library called as IO. Okay. First, I have imported a library called as IO. After importing the library called as IO, I have just called a function called as bytes IO to convert into the proper format, the file into the proper format, proper bytes format. And then I have given my file, my variable, which I've loaded here, along with the file name. That's it. Once you do this one, okay, now your data will be in the form of proper format, in the form of bytes format. So I'll just say bytes file. Okay, I've taken a variable here, one more variable called as byte underscore file, and I've just taken here. Now, once you have converted your data into proper byte format, now you can read your data set happily. How do you read your data set? You can simply say PD dot. In pandas, PD is nothing but pandas, guys. In pandas, we have a function called as read CSV, read underscore CSV. Basically, when you say read underscore CSV, we already know that CSV is for comma separated values. I told you already, right? CSV is nothing but comma separated values. But you're using the same read CSV function for reading a TSV file also. Okay. For reading a TSV file also, we can use the same read CSV function. Basically, by default, read CSV will expect your data in the form of comma separated values, right? Read CSV will expect your data in the form of comma separated values. But what we can do here is, we can apply some technique here and we can actually convert into the form of tab separated values. So let me show you how we can do that one. So in this read CSV function, guys, you can pass your bytes file. You can pass your bytes file, whatever you've done, converted into bytes format. Once you've done this one, if you run this code, you'll be getting an error here for sure. You'll be getting an error. Let us understand what is error actually. It says parser error tokenizing your data. The meaning of this particular parser error, I told you, right? Because by default, your CSV file accepts your data in the form of a .csv format, but your data is in the form of TSV format. It is in the form of tab separated values, not a comma separated values. It is in the form of tab separated values. In that case, what we should do here is, we have one more attribute called as delimiter. In your CSV, what do you call this particular CSV extension? We have a parameter called as delimiter. In delimiter, by default, the delimiter is comma, because by default you are actually importing a comma separated values, or you're using comma separated values. But we know that we are working with a tab separated values. Generally, can I know how the tab is represented by? How do you represent a tab generally in programming? When you speak about programming, how do you represent tab? How do you represent tab in programming? Can you know how you will represent tab in programming? Anyone?
Slash T, sir.
Perfect. Slash T, right? Slash T. See, by default, delimiter will be comma by default because it is a read CSV file, read CSV extension. But the disadvantage here is we don't have any separate function called as read TSV for reading a TSV file. So what we can do here is instead of comma, we can go for slash T. When you go for slash T, just a second. Just a second. If you go for slash T, you can actually read your file. Okay, getting some empty data. So let me check it. IO.bytes, IO, assurance TSV. Let me run this code once again. Yeah, perfect. It is imported, so no problem. So you can see that, right? You can see that here we have slash T. See, whenever I give a comma here, I got an error, right? You got a parser error. Or if you go for comma, also be getting a parser error. By default, delimiter is comma. But you know, now whenever I say delimiter is nothing but separation. Separation. How do you want to separate? How do you want to delimit? How do you want to separate your values? How your data is separated? So whenever I mention slash T here, whenever I mention slash T, you can see that your columns are separated because you know that in TSV, I already shown you that in TSV, you can see that the columns are separated with tab space slash T. You can see here this review and this liked. This is your review and liked. Review and the output. The review and the output. It is separated by tab. The same thing you can see here. Now what I will do here is now your data is in the form of data frame here. This is nothing but a pandas data frame. This is nothing but what you're seeing is nothing but a pandas data frame. Now I'll try to load this particular data frame in a variable. I'll just say it as data set is equal to. Okay. Perfect. Now if you look at my data set, here is my data set. Okay. You can see this is my data set right now, which has one column which has reviews, and other column we have liked. That is your label. Means 1 means it's a positive review and 0 means negative review. Now using this particular data set, I'll be building a smart NLP based system, like a smart sentiment analysis system, which helps us to analyze the sentiment whenever I give a new review. Okay. So any doubts up to now in this particular code? Any queries? Any doubts up to now? Any doubts up to now? Clear?
Yes, sir.
Perfect. Perfect. Yeah. Okay. Once you have done with importing your data set happily, once you're done with importing your data set, then what you can do here is you can actually start working with this system, this data pre-processing. So if you see, observe here in our presentation, we already seen here that the very first step is applying. We'll be having some text documents. From the text documents, we'll be doing the text pre-processing. Then you'll be exploring the text, fiction engineering, and all those things. So we already have the text documents here. We already have the text documents, and these are the text documents we're having right now for applying some kind of sentiment analysis system. Now, what we can do here is we can do some text pre-processing here. We can apply some kind of text pre-processing, text mining, I can say, to implement this kind of system. So let us start with text pre-processing. Okay. 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 I'm just trying to create a heading. Okay, whatever. So now let us start with text pre-processing. Now, for doing this particular test pre-processing, guys, we'll first slice the review column from your data set. We'll try to slice your review column. So we have two columns here. We have review and we have liked. Okay. So we'll try to slice review column from your data set. So I'll try to slice that one. So if you want to slice your review column, you can just provide like this. We can say data set of review. So in this data set of review, you'll be having all your restaurant reviews. You can see that you have approximately 1,000 reviews here. So your indexes start with 0 and you have 1,000 reviews here. So I'll do one thing. I'll start applying my text pre-processing to the first review first. I'll be applying to the only first review. Then later on, I'll be applying for all the reviews. Okay. So I'll just take first review here. In order to take my first review, I'll just say review is equal to data set of review of 0. Of 0 means the first review, right? Because you know that the index of the first review is 0, right? You can see here. So if I say data set of review of 0, in your review, you'll be having the review, the first review. You can see the first review is wow, loved this place. This is my first review, what I'm having right now in my corpus, in my entire data, in my entire documents. This is my first review. What I will do here is, I'll be first applying my text pre-processing to my first review first. Then later on, I'll be applying for all the reviews by creating some kind of loop or something. Okay, perfect. Now you can see that in this review, whatever I'm having right now, you can see some kind of dots here, right? Or if you see other reviews, you can see some question marks or commas or like punctuations and all those things. You can see some dots. Now let me ask a question here. In order to analyze the sentiment of a text, for example, if I say wow, love this place, if I say in this way, do you consider this comma, full stop and all those things into the consideration? Do you need this kind of data like comma, full stop and question mark and all those things?
I think yes, sir. It's
Depending
considered.
upon what analysis again. For example, if you want to go for sarcasm or those kind of thing, then it is different. But when you are building a simple sentiment analysis system, and here we are not going for, again, one more thing what I want to convey here is, we are not going for any semantic relationship. Semantic relationship means what? Identifying the relationship between first word to second word or second word to third word. Here we are building a sentiment analysis system based on each and every word present in our review, based on the positive and negative words present in our review. So in this review, the positive words are like wow and loud, right? So in that case, this kind of dots and question mark and punctuations and all those things might not be helpful for me identifying the review, whether it's a positive review or whether it's a negative review. For especially when you're building a sentiment analysis system, this kind of thing might not be helpful for me, right? Or the data which is not especially punctuations. Many of these punctuations is not important for me. So the very first step is removing the unwanted punctuations. So in the very first step of text mining or text pre-processing is removing the unwanted punctuations. Okay, removing the unwanted punctuations. Punctuations, when I say question, it might be full stop, question mark, it might be multiple things. So how do you remove it? How can you remove this? You can remove this by using a technique called as regex patterns. Regex patterns. We basically called as RE, regex. By using regex patterns. What exactly is regex patterns? Let us understand right now. What exactly is regex pattern? So generally, guys, when you are actually filling a form, for example, if you go to a website and you're trying to fill in a form, or you go to you go to your Gmail, you log in, right? Now I'll go to form and I have a tab called as email, right? I have a tab called as email here. I have a tab called as email. In that email, if I enter like this, if I enter my email ID like this, is this a valid email? Is this the valid email?
No, sir.
No, right? It is not a valid email.
Yes.
Right? Because generally, when you have an email ID, you'll be having @ you'll be having some kind of domain name, you'll be having dot, and you'll be having some kind of com, something, all these kinds of this one. This is nothing but a valid email. Okay, this is not a valid email ID. When I say GD Abhishek, not a valid email ID. Then how your form is able to identify it's a valid email ID or not? With the help of regex patterns. Regex patterns. So a pattern which will be helping us to recognize some kind of text, some kind of pattern in the text, that is called as regex patterns. For example, if you want to recognize an email ID, what email ID contains? First, email ID should contain A to Z, or it might be contain numbers also. In my email ID, I may also have numbers. So 0 to 9 is okay for me. I'm forming regex patterns. So either it may be A to Z, either I can go for small A to Z or small capital A to Z, whatever. And I can have numbers. And after numbers and A to Z, what should I have? After numbers and A to Z, whatever, what should I have next?
At the rate.
At the rate, for sure, right? I should have at the rate. After at the rate, again A to Z. It may be any domain name, A to Z. It might be gmail.com, yahoo.com. It might be facebook.com. It may be anything. Domain name, right? A to Z. It might be anything. After domain name, dot, because domain name dot. It might be anything again, A to Z. It might be .org, or it might be Gmail. Sorry, it might be .com, .org, .in, .net. It might be anything. This is a regex pattern for email. I'm just giving an example here. So if you follow this pattern only, then only we can say it's a proper email ID, right? One more example. For example, let us consider I want to identify mobile. Generally, Indian numbers start with what mobile number? What's the mobile number? Indian mobile number start with?
91, sir.
Plus 91, that is common, that is code.
Yes,
apart from code.
Yes.
Okay, plus 91 is a code. Apart from code?
It's a 9. Start from 989 like that.
Can I start with 6789?
Yes.
Yes. Mobile number can be, because right now, according to according to the this particular government, we are starting from 6 to 9.
9.
It may be 6, 7, 8, 9, and followed by 9 numbers. Here it should have only one number, and followed by how many numbers? Any number from 0 to 9 up to 9 numbers, right? Already one number is occupied here. 9 numbers. Exactly 10 numbers should be up. You should have 10 numbers. Then only we can say it's a proper mobile pattern. I'll just show you the mobile pattern also. If you just go to Google and if you just search for mobile number regex, Indian mobile number regex, because for foreign mobile numbers it is different. Okay, Indian mobile number regex. So you just go to Google and just search for this and find out here. You can see the regex pattern in this particular website somewhere here. Yeah. Yes, you can see here. It starts with 7 to 9, or 6 to 9 also. Now it is 6 to 9, 0 to 9, and this. Now you can see here it is updated also. Where is this? I guess this guy is not updated, but you can see here. So these are the patterns we use for identifying something in the text or identifying something in this. This is called as regex patterns, and regex patterns are one of the most important thing when you're working with NLP. You can see here. Yes, we have this one. So this is nothing but the, see what does this means? This is start of the regex patterns and the end of the regex pattern. So generally we'll be using this notation for starting of the regex pattern. Starting of the regex pattern, this is the notation, and ending of the regex pattern. Starting with cap symbol and ending with $sign. It can start with 6 to 9, and after that you should have digits. D means digit from 9 to 9. So you can see here. He explains this also. So match the beginning of the string and match the end of the string. So it starts with beginning of the string and end of the string. Match between 7, 8, or 9. Here it is 6 to 9, means 6, 7, 8, or 9. And match a digit from up to 9 numbers. It might be 9 times. It should be 9 times. This is a regex pattern of an Indian mobile number. If you don't follow this pattern, then automatically, this is how Google, these are how forms work. Okay, normally when you're filling a form, these are how forms work. And the same regex pattern concept we'll be using in NLP in a lot of times, when you want to identify some patterns and everything. Okay, so we'll be using the same regex pattern to implement this one. So for implementing this regex pattern, guys, we have a library called as RE. We have a library called as RE. RE stands for regex. So what you can do is you can just go to this particular notebook and you can just simply say import RE. Okay, import RE. RE stands for regex. Once you have done importing your RE library, that is your regex library, then you can use a function called as So in this case now, why I'm using regex here? Now you might doubt why I'm using regex. Why I'm using regex? Because in this review, whatever I'm having right now, in this review, whatever I'm having, I should remove some unwanted text, unwanted punctuations. I want only the alphabets from A to Z. I don't want any like any other than alphabets, because I'm working with text pre-processing right now. I'm working with text pre-processing. So in that case, what you can do here is you can apply a regex pattern and you can use a function called as sub. Sub stands for substitute. Here, sub stands for substitute. In this substitute function, guys, you can give what all you want to substitute apart from this pattern. Means here you can give a pattern here. You can give a regex pattern. Here I'm giving a pattern. Just carefully observe here how I'm giving a pattern here. Here my pattern starts like this. Carefully observe. My pattern starts like this. Starting of my string to match my starting of my string. A to Z. So anyway, I'm okay with A to Z, capital A to Z, small a to Z, or capital A to Z. Okay, uppercase and lowercase A to Z is okay for me. Means apart from this regex pattern, if the RE finds any other regex patterns, it will substitute with what? So the first argument you should give your first you have to give your pattern. After giving a pattern, you can give a comma here, and what you want to replace in the substitution, I'll replace with a space. So what you're doing here, you are applying a regex pattern to this particular review, what I'm having right now. When you're applying this regex pattern, this particular review, the reviews which are not actually small a to z and capital A to z, which are not small a to z and capital A to z, means which are not alphabets, I'm removing those. I'm substituting those with an empty string. And the third argument is, in this particular function called a substitute, the third argument is to which review you want to identify, to apply. Now, I have my review in which variable? I have my review in which variable? In a variable called as review, right? I can apply to review. That's it. So, RE regex dot substitute. Apply this regex pattern, means whichever not. Substitute means replacing, which are not small a to z and capital A to z with an empty string to the review. When you run this code, look at the difference between this review and this review. What do you observe here between this review and this review?
So dotted part is not there.
So I can say that punctuations are removed and unwanted punctuations are removed and replaced with space, right? Yes. Right. So you can see that it means that RE dot substitute, which is not A to Z and small a to Z and capital A to Z, replace with empty string, and apply to review. That's it. Now what I will do, I'll update my review like this. I just say review is equal to RE dot sub. Now you can see my review is updated. My review is updated with a string which is actually removing, where we have removed all the dots and all the punctuations and everything. Perfect. Once you're done with this step, our next step is, after removing this particular punctuations and everything, our next step is lowering your text, making your text into lowercase. Why do we need to apply this step? Let me explain you something here. Let me explain you this particular thing. Let us consider you are working with the sentiment analysis system, and in this case, what you're doing here is, in your first review of your data set, you have a word called as wow like this. In the 10th review, you have a word called as wow in this way. Just observe the difference here. Now, this is my first review. In the first review, I have a word called as wow. And say 10th review, I have a word called as wow. In my 10th review, I have a word called as wow. Now, I want to make one statement here. I want to convey one thing here to people, that when you're working with this kind of NLP-based systems, each and every word in our reviews are our features, are our important features, means inputs, are our independent variables, are our features for building a machine learning or deep learning algorithm. So here in the first review, we have capital wow with capital uppercase and smaller wow. Now let me ask a question here. Now can I say that the meanings of the both words are same? The meaning of the both words are same here?
Both are same, sir.
Of course, right? Both are meaning the same here, right? But the only difference is the way they're denoted. Here it is uppercase in the lowercase. So when you're trying to build a feature representation, because ultimately after doing the test pre-processing, if you look at this particular this thing, after ultimately after implementing this particular text pre-processing, you have to implement that particular text in the form of a featured format, in the feature format, in the neat features format. So when you want to implement the particular text in the form of features format in the neat feature representation, okay, neat feature representation, you have to, okay, you have to consider this wow and small wow and capital wow. What happens means whenever you represent your data like this, it will be like this: capital wow in one variable and small wow in other variable. So your model assumes that, your machine learning model or deep learning model assumes that, because we are making our model to learn from this data, right? So your model assumes that this small wow and capital wow are different, but in actual case they are same. Getting my point? It will assume that this capital wow or small wow are different, but in actual case they are same. In actual case they are same words. So in order to avoid this problem, we have to normalize your data. When I say normalize your data, we have to get your data into one single format. So we can apply a lowering here. We can apply lowering of text. Means we can convert our entire text into a lowercase. We can convert our entire text into lowercase. So how can we do that one? Simply what we can do here is, we can simply call review dot lower here. So instead of, what I'm doing here is entire text I want to make it lower. So wherever we have uppercase, it makes it to lowercase like this. Wherever we have uppercase, it makes it to lowercase. In that case, first review also will be having wow, and second review also, or 10th review also will be having the small wow itself. In that case, your model will be assuming it as same word. That is the reason we apply this step. See, every step, whatever we apply, has a reason for that. Okay. So whenever we make review dot lower, you can see that you have lowered your text. You can see entire text has been converted into the lowercase. You can see here your text is right now in the uppercase, but now your text is converted into the lowercase. Lowercase. Perfect. Perfect. Done. So our next step is completed. Next step of data. See, I'm applying for only one single review, but don't worry. Once we're done for one single review, we can run a simple for loop and we can do for all the reviews here. Okay. So you can see that now we are done with for this particular review. Done. Perfect. Now after this step, what is the next step we have to do? The next step is, of course, you have some space here to remove the space and all those things. Of course, we can remove. Now let me ask you a question, guys. Now if I say like this is a wonderful place. Now what is my sentiment here? What is my sentiment here? Can I say in this way, like this is wonderful, this is a wonderful place? What is my sentiment here?
I think, sir, it's your
Positive. I'm positive,
positive.
right? My sentiment is positive here because I told it as is a wonderful place. When I say it is a wonderful place, means my sentiment is positive here. Means I am happy with this. I'm happy with the place. My sentiment is positive. Now let me ask a question to you people. In order to tell that this review is positive or negative, are you considering the word like is or a or this kind of words? Are you considering these words right now? Like is, a, those kind of words, are you considering that one? Are you considering this kind of words like is, a, or this? Or for example, I just say wow, loved this place. Now, in order to say, now we know that it's a positive review, right? This is also a positive review. In order to say this particular review is a positive review, are we considering this keyword for telling that one? Are we considering this in your mind? Just imagine. Because ultimately, the way we think, the way AI thinks, okay? Because we are giving our brain to our AI system. Now, whatever pre-processing you're applying here, it is a pre-processing what we think, what we analyze, what a human thinks. Now, to analyze this wow, love this place as a positive sentiment, do you consider this as a important word in your brain? Will you consider this word as an important word in your brain? No, right? will not consider. Will not consider this kind of words as important words to analyze is a positive or negative. See, for example, if you're building a chatbot system or when you're building some kind of other kinds of analysis-based system, you might consider this particular is or a word, or you're building a translation. For example, you're building an machine translation, you might consider these words. But here we are not building any kind of chatbot or you're not building any kind of translation system. You're building just a sentiment analysis system. You're building a sentiment analysis system. So when you're building a sentiment analysis system, you might not consider these words like this kind of words. Basically, these words are technically called as stop words. Stop words. These words are technically called as stop words. So stop words are the words which are most repetitive and non-important for our end use case. Like the words like is, a, that, this, all those kinds of words which we generally use for completing the sentence or joining the sentence or just forming a good sentence. That's it. We use these words only to form a good sentence. But ultimately, my end goal is not using this particular word. I told you already. When you are working with any kind of sentiment analysis system, you need when you're working with an NLP system, every text, every word will be an independent variable. Every word will be your feature. Okay. So when you are using this particular word like is, a as an independent variable or the feature, these are the most common words which we see in negative review also and we see in positive review also. So these words are not used. Yeah. Any doubts? Any doubts, anyone?
No, sir.
Okay. So in that way, we can remove this one. See, here ultimately we are not finding out semantic relationships. We are best finding out the words. Based on words, we are finding out the sentiment. Okay. That is how it works. Okay. So now let us try to use this stop word. So what we should do here is we should remove this kind of stop words which are not needed to us. In order to remove the stop words which are in our reviews, we can use a library called as stop words itself from NLTK. So let us import that one. First, our first step is to import a library called as NLTK. One more library called as NLTK. What is NLTK? NLTK is the most library when you're working with NLP. When you're working with NLP, NLTK is the most important library. NLTK stands for Natural Language Toolkit. Natural Language Toolkit. So in this particular library, guys, you'll be having all the required operations and all the required important systems for building a sentiment analysis, or not only sentiment analysis, for building any kind of NLP based systems, or when you want to build kind of any kind of natural language based systems, you can use this particular NLTK. This NLTK supports few languages, like it supports few foreign languages itself. But for example, if you want to have Hindi, or when you want to have Telugu based natural language processing, you can use a library called as INLTK. INLTK supports Hindi also. Means if you have a restaurant reviews of Hindi language, you can also use the same process for using for Hindi language. Means you can also make your system understand Hindi language also by using INLTK library. I stands for Indian languages, right? But we are using NLTK because we are working with English language right now, so we can use NLTK. But in future, if you are working with any kind of Indian languages, you can happily use INLTK to implement that one. INLTK. Okay. So now after importing this NLTK, in this NLTK, I have a function called as downloads to download my stop words. See, I told you what are stop words. Stop words are the words which are not important for my end use case, for my end model building. So download those. If you want to download the stop words, simply you can say NLTK dot download. It is for sure, guys. You have to first download all the stop words. So NLTK dot download, and here you can give stop words. So download. You can give stop words in this argument. So if you say NLTK dot download stop words, it will download the stop words from the internet. If you have internet connection here, you can see here stop words, not stop word. It is stop words. Perfect. So you can see right now it is downloading package stop words to this particular folder, and it is unzipping this one. Perfect. True means perfect. So now what you done here, you have downloaded stop words. Means here basically, guys, you no need to write the list of all the stop words you want, because there are multiple stop words in English language, like a, as, that, this, that. We don't write all the list. We need to create a list manually, automatically based on the, so it is automatically created by multiple researchers. Okay, so we can use that stop words directly. So once you download this particular stop words, now you can import the stop words library. So you can simply say from import a stop words library. You can simply say from nltk.corpus. Basically, the meaning of corpus is nothing but group of text documents, guys. Corpus, the meaning of corpus is group of text documents. Group of text documents. Okay, that is the meaning of corpus. Okay, so we can simply say from nltk.corpus, import stop words. So basically corpus is a package in NLTK. In that we have a class called as stop words. Okay, so we can use this particular stop words for actually implementing the stop words library. Okay, so once I've done importing the stop words, then I can start applying the stop words to my data. I have to open my stop words. Let me show you how you can use this particular stop words. Okay, so what you can do here is you can simply say like this. You can say stop words dot words. Right now in this words, see, I want the list of stop words, right? Basically, I want the list of stop words which I can review. I can remove from my my corpus from my document. So I can simply say stop words dot words. In that, which language I'm working on right now? English, right? So you can give English. That's it. Whenever you give stop words dot words English, you can see you got all the list of stop words here. In these stop words, you might have a words which are important also. I'll tell you how to use that one later on. But these are all the list of stop words. Like you can see here. I, me, myself, we, ours, all this list of stop words. Of course, in these words, there are some important words also which you can use later on. I'll tell you about that later on. But I'll just take in a variable called as SW. In now, after initializing my SW here, in my SW, I'll be having all my list of stop words. You can see in SW. Okay. Now I have my stop words, right? I have my stop words. After having my stop words, what I will do is I'll write a simple code. To remove my stop words from my list, from my data. Okay. Here my end goal in my next step is we have your review, and this review is your text, your string, your review. Now from this review, I have to remove my stop words because the words which are not important for my end goal, that is for implementing this one, for implementing some kind of sentiment analysis, this kind of text is not needed, like this, a, and that, all those things are not needed. So I can remove those kind of words. So in order to remove the stop words, what I will do is I'll take a simple logic here. I'll build a simple logic. I'll take a empty list, one more empty list here. I'll just take a empty list called as b is equal to empty list, and I'll iterate through each and every word in the review. In order to iterate the review, I have to convert my string into the form of list format. So what I can do, I can simply say review dot split. I can use a function called as split, and I can convert each and every word into the form of list format. You can see here now the review whatever I'm having right now, I've converted into the list format. Why? Because what I'm doing here. Why? Because I'll iterate through each and every word in the review. I'll compare with the stop words, whether the word is present in stop words or not. And if the word is present, I'll remove from the review. That is my end goal. Okay. If the word is present, I'll be removing from the stop words. So in order to do this particular step, I'll be iterating through the review. So let's say I'll update this one. I'll update this review. So now we can see my review here. I have the list of all the reviews right now. Here you can see I have a list of all the reviews right now. List of all the words in the review. Wow, love this place. This particular step is called as tokenization. You can note down this particular point also. Means forming your entire review in the form of tokens. See, each and everything is called as token, guys. Each and every word is called as token here. Token. This is a token, this is a token, and this is a token. So splitting your entire review into form of tokens, separate tokens like this in the form of list is called as tokenization. This particular step is called as tokenization. So in this tokenization step, okay, in this tokenization step, you are converting your entire review into the form of a tokens format, into the form of tokens format for implementing my stop words, for removing my stop words. So now what I will do, I'll just say for word in review, I'll iterate through each and every word in the review. So I'll just say print word. Okay. The moment I say print word, it is iterating through each and every word in the review. You can see we got loud, list, and place. Now what I will do here is, now I am iterating through each and every word in the review. Okay, before proceeding, up to here, clear to everyone, any doubts? Any doubts in this code till now?
No, sir.
Any doubts in this code up to now?
No, sir. No.
Remaining people? Clear up to now? Okay. So now what I will do here is, I'll compare now each and every word with my stop words list. I have my stop words list in a variable called as SW. You can see that. In a variable called as SW, I have my entire stop words list. Okay, in a variable called as SW, I have my entire stop words list. So what I will do here is, I'll be comparing this each and every word with the stop words list. And if the word is present, if my word is present in the stop words list, I'll remove that word, or else I'll keep it as it is. So for that, I'll write a simple logic here. I'll just say if word not in. So this is a you know what is this, right? This is nothing but your, in Python, not in is nothing but a matchable operator. We call it as matchable operator, right? So we are applying a matchable operator, more clearly comparison operators. In comparison operators, you're matching it. So if you word not in review is nothing but, sorry, for word not in SW, means if that particular word which I'm iterating right now, if it is not present in the stop words list, then what I will do here is, if the word is not present in stop words list, what I will do here is, I already created an empty list here, right? Empty list, which is having D. I'll just say D dot append. I'm using a function called as append, and I'll be appending the word. So if that particular word is not present in my review, if the particular word is not present in the stop words, I'm just appending to D. If I run this code, guys, let me see what happens. If I run this code, and if you look at D here, in this D, you got this one. So can anyone tell me what happened here? Just observe here between D and review. Just compare between D and review. What happened here?
Sir, this is removed.
What happened here?
Only this is, sir, this is removed. Word this is removed.
Yes. So I can say that the word this is removed, right? You can see. So what happened here? It means that the word this is present in the stop words, SW. The word this is present in the stop words. So what I'm telling, if word not present in stop words, so it starts with wow. It compare wow with SW. So wow is not present in SW. So it will append to D. Then it starts with loud. It will go with loud. Loud is not present in the SW. So it will append to D. This is present in SW. So it will not go to this if condition at all. Place is not present, it will go. So now we can see that now we have a review which is not having this. Means the stop word has removed. Stop word has removed. Now what you can do, we can update your review like this. You can update your review like this. So we can say review is equal to. Okay, now we can see a review which is not having this keyword. Perfect. Now what you've done here, you have removed your stop words. Done. This is the next step. Removing the stop words is the next step. After removing the stop words, our next step is stemming. And also we can apply one more kind of technique called as lemmatization. Okay, stemming, we can apply stemming. And also the other way of stemming, other way of this one is lemmatization. Let us understand what exactly is stemming first. Okay, let us understand what exactly is stemming. The other one of the most important pre-processing technique is stemming. Let me take an example here. Look at this word here. We have wow, loud, and place. Let us take this particular word called as loud. Let us consider in my first review, I have the word called as loud here. Okay. And if I go on, somewhere in 10th review, also I have word called as loud. Now I'll just say like this. I love this place. I love this place. Look at these two sentences here. Look at these two sentences. Or look at this particular two reviews here. I love this place and I love this place. Now, when you compare these two sentences, is your sentiment changing here? Is your sentiment changing here? Here also, the sentiment is positive. Here also, the sentiment is positive. First thing. Now, how you are telling the first word, first review and the 10th review is positive? How you are telling first review and 10th review is positive? Based on what? Based on which word you are considering the first review and 10th review is positive?
Sir, love.
Basically loud, the word loud, right? So if you have the word loud or if you have the word love, ultimately both are same meaning. But what is the difference you see in loud and love? What is the difference you see in loud and love?
Spelling, sir. ED.
Tenses. Can I say tenses? Tenses, ultimately. Right?
Yes, yes, sir.
Yes, yes. So what happens here is, I already told you, when you are applying your NLP model, when you are creating a feature space, especially when you're creating this particular feature space here, like when you're representing this in the form of a feature engineering, like in a space, feature space, what happens means every word in your corpus or every word in your document will be considered as an independent variable, or every word is considered as an input as a feature. So in that case, let us consider a word like this, loud and loud. See, ultimately both represent same meaning. Loud or love represents the same meaning. But the problem here is with the sentences, with the tenses. So to avoid this problem, we can apply stemming. Okay. Again, stemming should not be applied for all the NLP use cases, guys. I'm telling about sentiment analysis only. But for example, you have machine translation. In that case, you should not apply stemming. Or for example, you have chatbot, building a chatbot or something. There you might require tenses. But when you're building a sentiment analysis system, you might not require tenses. In that case, you can apply stemming. So what is stemming means? Converting a word into root format, converting a word into its root form. When I say root form, means, for example, if you have a word called as loud, converting into root form means normalizing your words more clearly. Root form means more clearly normalizing the words. Normalizing means getting your all words into one single format. Normalizing. This step is called as normalizing also. Normalizing means getting your entire words into one single format. Or for example, you have like this, the words like played, play, playing. See, ultimately, for building a sentiment analysis system, these three represent same. So I'll just make it as play. Or you have like this, for example, best, better, or not this. Okay, let us say, yeah, you can take this loud, loving. Also, this all comes under. We can convert all these words into a root format. So what is stemming is nothing but converting your word. Okay, converting your word into a root format. Okay, converting your word into a root format is called as stemming. Okay, converting your word into root format. So let us try to implement stemming. Let me show you what happens in stemming. Okay, let me show you what happens in stemming actually. In stemming, what happens means, first you have to, for applying the stemming operation, you have to first import a library called as Potter Stemmer from NLTK library. So we can simply say from NLTK dot stem dot porter import porter stemma. This is a library, guys, present in NLTK. So it is present in stem package in porter package, in stem and porter package. It is present here, and you can see here porter stemma. So first you have to import this particular class. This is a class actually. Porter stemmer is a class. It is a class present in nltk.stem.porter library, porter package. After importing this particular class, what you can do is you can simply say you can create the instance of the class. You can create the object of the class. So you can create the object of the class by like this, by using the constructor. So you can simply say you can initialize your class like this. So PS is equal to porter stemmer like this. After that, what you can do here is you can apply stemming. You can apply stemming here. So let us try to apply stemming like this. So if I say PS dot, if you want to apply stemming, so first you have to initialize your class. First you have to initialize your class. Okay, first you have to import your class. After importing, you have to initialize your class. After initializing, you can use the methods in your class. So you can see now, we can say simply as ps.stem. ps.stem. Okay, stem is a function to apply stemming. Okay, so stem we can use for applying stemming. Applying stemming. Okay, so you can simply say ps.stem, and here we can pass our word here. Whatever word you want to convert into root format, you can pass here. So I just say it as loud. What happened to your word when I passed loud here? What happened? It has converted into loud, right? And if you pass playing, it has converted into play. Or if you pass some kind of words like yeah, you can try different words. Better is as it is, and you can try some ing words and some kind of words you can try with stemming here. Okay, with different stemming. So what happening here? It's converting to root word. This is what stemming is. This is what stemming is. But there's a problem. There's a disadvantage in stemming. There's a disadvantage in stemming. Actually, stemming, what happens means, how stemming works means, if you ask me how stemming works means, it will remove the suffixes. Okay, it remove the end suffixes like this. If you have play in, it will remove ing. It might work. It might be working for some words, but it might be not working for other words. Let me show you a practical example also. But how stemming works means, it will remove these end suffixes like this, playing, like this, all those things. But it might work. It might not work for other kinds of words. For example, if you are like this, like for example, you have tasty. Is it a proper word? Is this a proper word here right now?
No, sir.
Or for example, you have trouble. This is the main disadvantage in stemming. Of course, stemming does something. Stemming is actually convert your form into root form. But the problem here is some kind of words will be affected by this. We can see here news. It is like new. So entire meaning of the word is changing by applying stemming. That's the main disadvantage in stemming. So because it removes the end suffixes. So sometimes you cannot apply a root format, means you cannot get a dictionary format word. When you apply stemming, you might not get a dictionary format word. In that case, you have to go for lemmatization. The same kind works, but it's slightly different. Lemmatization. So we have seen the disadvantage of stemming, right? We have seen the disadvantage of stemming. In stemming, you can see that for some words it is working perfectly right. But some words, as it removes the suffixes, it might not form in that. It might not be in the form of dictionary format. Okay, so it will be a problem for us. So in that case, you have to go for lemmatization. In lemmatization, guys, it converts the same thing. It does. It converts the root into a root format only. It also does the same thing, but the way it does is different. In stemming, what happens? It removes the suffixes. The end suffix, it will remove that one. But in lemmatization, it converts. It actually uses POS tags. we call it as parts of speech. POS stands for parts of speech tags. So in lemmatization, guys, you'll be having a entire dictionary of all the parts of speech. By using this particular parts of speech tags, it converts into a proper root format. So lemmatization is more accurate when compared with stemming, because in lemmatization you'll be having a dictionary words which will be helping us to convert your original word into a dictionary format. Sorry, into a dictionary format in the root format only. So this kind of problem will be avoided when you apply lemmatization. Okay, this kind of problem will be avoided when you're applying lemmatization. Okay. Okay, let us see practically how lemmatization is applied and how can we actually go with lemmatization. Okay, let us see right now. So in order to apply lemmatization, guys, in order to apply lemmatization, we can use the same stem library itself, but I'll tell you how, which kind of library you have to, means which kind of which kind of class you have to import. Okay, but understood what is stemming, everyone? Any doubts in stemming? Clear with stemming? Any specific doubt to anyone regarding stemming? Clear? Clear with stemming, everyone? So I guess everyone understood what is stemming and what is the main disadvantage in stemming. So in the main disadvantage in stemming is some words are perfect, some words due to the as it removes the suffixes, it will have a problem. We cannot remove some words might be converted into the different format. So that is the reason we go for lemmatization. In lemmatization, as I told you, it converts into parts of speech format. So let us apply lemmatization practically. So in order to apply lemmatization, guys, we can use a library called as WordNet Lemmatizer, which is in the NLTK stem package. So let's say from NLTK.stem package, we can say import WordNet Lemmatizer. We have a package called as WordNet Lemmatizer. So this particular WordNet Lemmatizer will be helping us to apply lemmatization to your data. Okay, it will be helping us to apply lemmatization to our data. So how can we apply lemmatization? Let us see. First, once we imported your WordNet, once you have imported your WordNet library, then what we can do is we can create the instance of WordNet. So how can we create the instance of WordNet means? Simply we can say WL or you can say WN whatever is equal to lemmatize. We can create this WordNet. After creating this particular WordNet instance, we can call a function called as lemmatize. We can call a function called as, in WordNet, we have a function called as lemmatize. See, here we will be using the function called as stem, right, to apply stemming. The same way, in order to apply lemmatization, we'll be using a function called as lemmatize. In this lemmatize, you can give your word. Okay, you can give your word. So let's say I'll give a word called as loud itself. Let us see what happens if I give a word called as loud. Got an error. Of course, this particular error is expected. Why you got this error? Because here the resource WordNet is not found. I told you already that lemmatization uses the dictionary of all the words for implementing this particular lemmatization concept, means converting your words into root word. It uses parts of speech tags, and parts of speech tags will be all in your library. So you have to download that. In order to download that, you have to implement this code. You have to use nltk.download WordNet. So let us try to that one. Okay. So before running this lemmatization, let us try to apply. Let us try to do this particular. So in your system, guys, when you're doing for first time, you have to do this one. You have to download this WordNet. So let us download that. So you can simply say nltk.download WordNet. Okay, because it has all the data for implementing the lemmatization. Once you do this one, reinitialize your model, reinitialize this one. You know your error is gone. Perfect. Your error is gone. But observe here carefully. After applying your lemmatization, is your word converted into root word here? After applying your lemmatization, is your word converted into root word here? Observe carefully.
No, sir.
No. Why? Because I told you right already that we'll be having a parts of speech tag here, POS tag. So we have to give a parts of speech tag here, POS tag. You can see by default the POS tag is noun here. You can see that by default the POS tag is noun. So whatever you give, you'll be getting the same result. But I want in the root word format. So to give the parts of speech as verb. You can also give it as V actually. V is better. Yeah, V, you can give V. V stands for verb here. Okay. You can just give it as V. V stands for verb. If you give it as N, N stands for noun. Okay. If you give N, N stands for noun. Parts of speech, guys, noun, verb, and all those things. So if you give noun, you'll be not getting in the root format. But if you give in the verb format, so you can see that based on the parts of speech tag what you are giving, it converts. So you can see loud is converted to loud. Now let us try with other words like playing, playing, play, or you can say trouble. Let us try with this word trouble. They get in trouble itself. See, this is the main difference between stemming and lemmatization, guys. You can see here. In stemming, what happened? If you apply trouble here, your E has gone because I told you, right? It removes N suffixes. But in lemmatization, not like that. It actually uses parts of speech or trouble, or we can try with this word like tasty. You'll be getting the exact word. Or you can tell me one word. I'll try that word. Dancing. Dance, right? Dancing has been converted into dance like this. So like this, whatever word you give here, it converts into the root form. And lemmatization will be so much accurate, and it will be from your dictionary format only. That is what lemmatization is. Understood? Understood clearly what is lemmatization? Clear with lemmatization? The main difference between stemming and
Yes.
lemmatization.
Yes, sir. Yes.
Perfect.
Sir, what is POS?
Pardon? POS, parts of speech. Parts of speech tag.
Okay, sir. Thank you.
POS. That is what I'm telling, right? So lemmatization uses parts of speech, POS tags, for actually converting your word into root form. So based on whatever parts of speech you have applied, based on that it converts. Okay. So POS here, V means verb. Verb. Okay. Here V stands for verb. If you go for N, N is nothing but noun. Like that, you can try different parts of speech. Generally, verb is used for converting the root word. Okay. So it converts your words based on the parts of speech. Got my point? Perfect. So now, after applying the lemmatization, now here we have applied lemmatization. You have just seen lemmatization, right? Now let us apply lemmatization for our data set. Already we have review here, right? We have your review. Okay. Let us apply lemmatization for this data set. I'll do one thing, guys. I'll do a small technique here. I'll do a small technique. Already we are running a for loop, because here, if you observe here, we have to apply lemmatization for each and every word. We cannot apply for entire list at one single time. So again, you have to run a for loop. Instead of running one more for loop here, what we can do here is, already we have a for loop here, right? Already we have a for loop. In this for loop itself, I'll be appending a lemmatization word. So let me show you what happens. What I will do here. Carefully observe. I'll just take the same code here. Okay, just carefully observe what I'm doing here. Okay. I'll do stemming, applying of stemming and removal of stop words at one single step. Okay, I'll do applying of stemming, or sorry, applying of lemmatization and removal of stop words in one single step only. I'll show you. So already I'm removing my stop words here. In this case, I'm removing stop words here. Okay. So I'll just say, I'll take an empty list here. So D is equal to an empty list. Okay. So I'll just create one more, this one. Okay. Okay. Now I have my review back as it is. See, now do you have stop word in this review? Do you have stop words in this review? Yes, we have stop words called as this, right? So I've rerun this code again, just to show you. Now what I will do here is, I'll do the removal of stop words and applying of lemmatization at one single step. So what I will do here, I'll just say, for word in review, if word not in SW, if the word is not present in the stop words, D dot append, whatever word I'm appending here, I'll be converted into the lemmatized format. So just observe carefully what I'm doing here. I'll just say WN of word. Look at this code, what I'm doing here. So I'll just say B dot append the lemmatized word, and I'm appending a lemmatized word, because already I'm removing the stop word here. So when I'm appending a non-stop word here, because here I'm appending a non-stop word. So whenever I'm applying a non-stop word, immediately I'm applying the lemmatization. So I'm just saying wn dot lemtize word, comma pos is equal to verb. The parts of speech tag is verb. So when I run this code, and if you look at D, the first thing is the stop word removed. Is your stop words removed? First question.
Yes, sir.
Is your words converted into the root format?
Yes, sir.
Yes. The words has been converted to root format. You can see that here. This was your review actually. Before applying this step, this was your review. Wow, loud this place. Of course, in the tokens format. Here in one single step, I am removing my stop words this, and also I'm applying the stemming. Okay, so here we can just say it as removal of stop words and applying lemmatization and applying lemmatization. One single step done. So now we can see your review, guys. The review is perfect right now. Now the review is perfect with the neat with the data which is required. Now what I can do here is I want to make it to a single text format. So what I can do, I can see right now it's a form of list format, right? List of words. We have list of words. Now I can remove in the form. I can make it to the text format. So that for that what I can use a function called as join. So I'll just say space dot join of D. If you use like this, what happens means wow love this place will be joined with a space. No sir, I want to join with comma. Do like this. Comma string empty string like comma dot join dot this dot D. So you can see wow love place will be joined with a comma. Or if you want to join with exclamation mark dot join dot D. Now I want to join with space. I'll be joining with space like this. I'll update it as review. So let's say review is equal to space dot join of D. If you look at my review right now, this is my review. This is how it looks. Wow, love place. Now here what we done? We have applied lemmatization. We have applied what do you call removal of stop words. We have done lowering. We have done all the text pre-processing. All the text pre-processing is done. So now your text is completely pre-processed and we can use for applying your model and doing some other all those things. So up to here clear. Anyone having any doubts here? Up to here clear what you done now?
Yes, sir.
Is
Yes,
there
sir.
any doubts here? In this?
No, sir.
Okay, perfect. Now if you look at here, in this whatever steps I've applied till now, I've applied for only one single review. The very only first review. Right? I've applied only for the first review. That is wow love this place. But ultimately, I want to apply for all the 1,000 reviews. Okay, I want to apply the same step for all the 1,000 reviews. So what I will do here is I'll take a simple for loop and I'll do the same thing for all the 1,000 reviews. So let us do that one right now. So I'll just say here. So if you look at my review here, I'll in my data set of review. If you look at my data set of review, 1,000 reviews here. So let us try to create a for loop here. Okay, let us try to create a for loop. So I'll just say data set, sorry, for I in range. So why I'm using range? Because I have 1,000 reviews here. I'm going from 0th review to the 1,000 reviews. For I in range 0, 1,000. First, I'll show you what happens if I print I. So if you print I, what happens means it starts with 0 iteration. It starts with 0 and goes up to 1,000. You can see here, it goes up to the 999, means last one, because indexes in Python start with 0 and end with 999, right? So you can see here. So 1,000, I went with up to 1,000. Perfect. After going up to 1,000 here, so in this for loop, I'll be applying all the data pre-processing what I've applied till now for one single review for all the reviews. So let me write this. Let me write this code right now. I'm just copying this code, entire code for running a for loop here. Okay. I'm just copying this code, guys. So you can see here, um, I'm lowering it and next. Splitting. Let me do it. Lowering it and finally applying the stop words. So let me apply the stop words also and apply this particular lemmatization. Okay. So splitting the review. I'll create an empty list here. Okay. Empty list. After creating an empty list. Okay. Then I'll just say for for loop here inside for iterating through each and every word in the review and appending it to D. Okay. And finally making the review like this. So if you observe carefully here, what all steps I've done previously, for one single review. Now I've done a code for writing for all the reviews. Okay. Now, can anyone tell me what is the change you have to do in this code for doing it for all the reviews? See, there is a small change here. There is a small change you have to do in this review to make it for all the reviews. Can anyone guess what is the problem in this code? There is a small change here in this code to make it for all the reviews. To do it for all the reviews. Anyone? Anyone can tell the change here? What is the change you have to do in this particular code?
So I think there is no any white space between wow, love, and place.
No, you will be having a white space. You can have a white space because later on, for applying a bag of words model, we need a white space also because to differentiate words here. Observe this. There's a small change. So look at the first first code here. In this first code, off zero means what? What happens if I take off zero? If I say off zero, data set of review dot off zero, what happens here? Can I say it will return the only first review?
Yes, sir.
But if I want to go for each and every review, what I can do, what I can make it the zero as? I can make it as I simply. Because we know that at I, first iteration in I is 0, second iteration I is 1, third iteration I is 2, 3, 4, 5, 6 like that. So it goes from 0th, you can see here, first iteration of I is 1, 2, 3, 4, 5, 6, 7, 8, 9, it goes up to 999. So it will be finding out for every review here. It will be finding out for every review. So it is I. Because if I say off 0, it will be doing for only one review. But if I say off 5, it goes for all the reviews. It goes for the entire reviews. So at the last step is, guys, after doing all the pre-processing, I have to save entire data in one single file, or one single variable, or one single list. So I'll take this list as corpus. I'll take an empty list called as corpus here. Okay, I'll take an empty list called as corpus. In this corpus, I'll be appending all my reviews which is pre-processed. Okay, so let's say a corpus dot append. At the last, after every for loop iteration, I'm appending all the reviews which is pre-processed here. Okay. Okay. So after every iteration of every, because we have 1,000 reviews, right? Yeah. So after every iteration of every for loop, you will be appending your corpus. Okay. Now I'll run this code. Now it is doing for all the reviews. Okay. There is some invalid syntax. Let me see here. Review is equal to join node. Just a second, guys. There is some indentation problem. Let me check it. So D empty list, and we are just doing the same thing, right? Let us see the problem. Okay. So after splitting, we'll try to apply the for loop. So let's say for word in review, word is not in SW, D dot append, wordnet dot lambda is this one. Let us see our D right now. So D is an empty list. So let us print D. Okay. So you can see all the list of data here, which we got right now, which is done for all the reviews. You can see this. We've done all the pre-processing for all the reviews here. You can see wow, loud, place, crust, good, and all those things. You can see here all the data pre-processing done for all the reviews. Let me join this with empty space. So let's say dot join of D. Perfect. Now I'll append to D. I'll append to corpus. So let's say corpus dot append of D. Yes, perfect. So done. Small indentation problem. That's it. It is now cleared. So simple, guys. So what I'm doing here is first I'm running the iterations from first to 1000. First review, it'll apply all the pre-processing. It'll append to corpus. So in this corpus, you'll be having all the pre-process reviews, guys. If you open the corpus here, you can see that here you have all the pre-process review. You can see here. These are all the pre-process reviews you're having in your corpus. Entire list of all the pre-process reviews right now. Okay, so you can see list of pre-process like wow, loud, place, crust, good, tasty, test and as steam, stop, late, bank, called something. All the text you have right now, which is actually pre-processed. We have removed all the punctuations. We have made it to lowercase. We have applied the stem. We applied the lemmatization. We have removed the stop words, and everything is clear right now. So up to here, we can say that of course there is some problem here. I'll tell about the problem also, but I can say that up to here the text pre-processing is completed. The text pre-processing is completed. We're done the text pre-processing of our data. Okay. So any doubts up to here, guys? Any doubts up to here? Any doubts up to here? In this code or any other code? Clear with this? So this is my first review, second review, third review, fourth review.
No, sir. No doubts.
Okay. So we have up to 1000 reviews here. You can see we have up to 1000 reviews. Now our next step after doing all the data pre-processing and all those things, our next step is to apply some kind of exploratory data analysis, EDA. Okay, EDA, exploratory data analysis. We can apply some kind of word cloud. We can visualize this particular data in the form of word cloud. Okay, in the form of a word cloud. So let us visualize your data in the form of word cloud right now. So let us see how to create a word cloud with the help of this one. First, let us understand what exactly is word cloud. Okay, so word cloud is nothing but especially when you have a lot of words in your data. Okay, when you have a lot of words in your data, and when you want to visualize that words in the form of a cloud format based on the frequencies, we generate is called as word cloud. More clearly, let me explain. In the word cloud, guys, for example, let us consider this particular corpus. Let us consider this particular corpus. In this corpus, let us consider we have a word called as, for example, in this corpus, we have a word called as love. Okay, we have a word called as love. Let us consider love is repeating a lot of times in your corpus. Okay, let us consider love is the most repeating word in the corpus. So in this visualization, love will be showing with the higher size. compared with the remaining words. So the size of the words are visualized based on the repetition, based on the frequency of the words, frequencies. Okay. So if you just go to Google and just see the representation of word cloud, this is how it looks. This is how a word cloud looks. This is how a word cloud looks. In this word cloud, you can see that here, the word embarrassment is very, you can see the size of the embarrassment is very high. Or affair, father, life. You can see these words are, the size of the words are very high with different colors. Or you can see this, in this word, the and, the wash is very high. Or you can see this word, or you can see this word cloud. So in this word cloud, the size of the words are depending upon the frequency of the repeating. Last session only you have learned about term frequency, right? Like how it is repeating in the intent document. So based on the frequencies, you can visualize this particular word. So let us see how to create this kind of word cloud in Python. Okay, with the help of library called as word cloud. This is called as word cloud. Okay. So with the help of Python library, let us try to create a word cloud. Okay. So let us try to do that one. In order to implement word cloud, guys, simply you can say from word cloud import word cloud. So we have a library called as word cloud to create a word cloud. In that we have a class called as word cloud itself, capital W and capital C. Okay, we have a library called as word cloud. In that we have a class called as word cloud. After creating the class, after importing the class, we can create the instance of the class. How do we create? We can simply say WC is equal to, we can say word cloud of, in this word cloud instance, it is just an instance, no need of giving anything here. There is no need of giving anything here. So you can simply say like this. And after creating the instance, in order to create your word cloud, guys, in order to create your word cloud, you can simply say WC, that is your instance of your word, generate. In this generate, you have to pass your word cloud you want to generate. Okay, means the words you want to generate from. So you can simply say WC dot generate. Okay. Now in this generate, guys, you have to give a, you have to give a words, you have to give the words which you want to generate in the form of a like word cloud format. So let me show you how can you do that one. So in this generate function, you have to give a corpus of wherever you have this one. So I told you, we already know that in this corpus itself, you have all the words, right? You have all the reviews. In this particular corpus itself, you have all the reviews. So in this corpus, you can pass, you can give this corpus inside the word cloud to pass it. So let me create that one, because in this corpus only you'll be having all the words. So what I will do here is I'll just say wc.generate corpus. But what happens means you'll be getting an error here. It says that export a string. You'll be getting an error because your corpus is in the form of list format, but it expects in string. So what you can do, you can just convert into a string format. So let me do that one right now. So you can simply say reviews data. So how do we convert a list into a string? Simply you can take a space and you can join all the elements, all the reviews into a string, like what we done previously. Join the corpus. If you see the reviews data, it will be entire string of all the words here. You can see all, it is a string. You can see entire string of all the reviews. Now, if you give this reviews data into the generate function, okay, it gives us the instance. It gives us the instance of your this thing. But I want to show, guys. Ultimately, I want to show my word cloud. I want to display my word cloud in the form of a graph, right? If you want to display your words, we have a library called as matplotlib. So let's say import matplotlib dot pyplot as plt. So matplotlib is a library for visualization purpose. If you want to visualize your graphs, when you want to visualize your data in the form of graph, we'll be using this particular matplotlib. So in this matplotlib, we can simply say plt.imshow. You can just say it as plt.imshow. And in this, you can pass your word cloud instance, WC. Now look at this. This is how your word cloud looks. So what I've done here? Let me explain you. First, after creating the corpus, of pre-processed data. I've imported a library called as word cloud for creating a word cloud. Then I've created the instance. My word cloud will accept the data in the form of string only. We cannot give a list, but your corpus in the form of list. So what I'm doing here, I'm taking one more variable called as reviews data, and you're converting your entire list in the form of string format, which is comma, which is space separated. So you have all the reviews data here. After having the reviews data, you're generating the word cloud from this, and you're showing in the matplotlib. You're just showing the particular word cloud in the using matplotlib library. So you can see this. Now we can see that here from this visualization, you can see that the words which are having the higher size or more size are highly repeated words, are most frequent words. So you can see that the word food is the most frequent word here. The word food is the most frequent word. The word good is most frequent word. Service, place, great, really, go, restaurant. So I can say that by looking at this review, I can say that whatever restaurant you're working on is a good restaurant. It's actually a good restaurant. Why? How I'm telling it? Because you can see a lot of positive words here. You can see a word called as good, which is a positive word. You can see a word like a word called as great. Of course, you can see also a negative word called as disappoint or go back. This kind of words also. But you can see positive words with higher frequency like service, best, good, place. So the words which are having the higher size is nothing but the words which are repeating a lot, means which are the most frequent words. The most frequent words are these words, you can see, which are in the higher size. This is how word cloud works. So you can see wait, of course maybe the waiting time of the restaurant is very high. Friendly stuff, wow, right? So you can see all these kinds of words which are highly repeated. This is how you'll be visualizing your word cloud to display your word cloud and understand something from your word cloud. Done? Understood? Understood how word cloud works? Any doubts regarding word cloud?
No, sir.
Perfect. Okay. Now, after this particular creating a word cloud, guys, after creating the word cloud, now our next step is we look at this process. So we're done with the text pre-processing. We're done with the text pre-processing, and we're done with the exploitative data analysis. That is EDA. We're done with the EDA. Our next step is to represent our text in the form of feature representation. So in our last session, you have learned about bag of words, right? You people have learned about bag of words. Yes or no? I guess you have learned about bag of words. Can I get a confirmation about that? Yes. In the last session, in the first starting of the session, you have learned about bag of words, right? Yes or no? Or you have learned about TF-IDF representation. TF-IDF representation. Bag of words and TF-IDF representation. You learned about this. Okay. Okay. So basically, when you want to represent your data in the form of a vectorized format, see, let me ask a question here. Right now, if you look at this particular data set, your data set is in the form of string format here. Your data set is in the form of a string and in this format. Now you cannot apply this data set directly to your model, to your machine learning model. You have to convert in the form of a numbers format into the form of a proper number format, in the form of numerical format. So we have a method called as bag of words, where based on the frequencies of the words, it will be converting into a vectorized format. So let us do the particular step here. So we can do like this. We can simply say we have a library called as scikit-learn to implement that particular bag of words model. So you can simply say from sklearn dot feature extraction. So basically we are working with feature extraction. So we are implementing the feature extraction step here. Okay, so we are applying this particular bag of words here. So feature extraction dot text, as we are going for text here. So what you're doing here, you're representing your words in the form of bag of words here, in the form of bag of words, in the form of a vectorized format. Vectorized format means in the form of an array of numbers, array of all the numbers here, of array of all the numbers. Okay, let me explain how it works. What happens means, based on the term frequency of the each and every word in your review, it will replace that particular word with a particular frequency. That is how it works. That is how bag of words works. Right? It will replace that particular words with a frequency. So we can simply say from sklo node feature extraction dot text import, we can use a library called as count vectorizer. Okay, we can use a library called as count vectorizer. Count vectorizer is nothing but your bag of words model. Count vectorizer is nothing but your bag of words model. Okay, count vectorizer is nothing but your bag of words model. Okay, means representing your text in the form of a count of the particular words. Okay, so then you'll be creating the instance of count vectorizer. Okay, you will be creating the instance of count vectorizer. After creating the instance of count vectorizer, then what you will do is you'll apply a function called as fit underscore transform into the corpus. Okay, and it will convert into a vectorized format. Okay, then you'll be converting into an array format to array. Okay, you can say it as x. That is nothing but an independent variable x. So if you look at your x, you can see that here your corpus has been converted into the numerical format, into the numbers here. What happened here right now? In this step, what happened? Let me explain you. For example, you have reviews, guys. You have multiple reviews. Let us consider you have reviews like wow, this place. We have like this. We have love this place. We have wonderful place. We have worst place. Okay. Now you have like this. You have your reviews like this. In bag of words model, what will happen means every review will be taken as a feature. Every word will be taken as a feature. So wow is one word, unique word. Love is a unique word. Place is a unique word. Wonder is nothing but unique word. This one. Now let me ask you, how many times wow is repeating in the first review? How many times wow is present in the first review? And worst also. Worst is a one more review. So how many times wow is present in the first review? One time, right? One. Now, one time. Place, 0. Sorry, one time. Wonder, 0. Worst, 0. So what happened here? Based on the frequency of the words present here, your words has been transformed to this format. Next. Here also, wow, 0. Love, 0. Place, 1. Wonder, 1. Worst, 0. Here, place and worst, wonder is present. There is no one wow, worst and wow. For example, in the first review, we have 2 wows. In that case, here the wow will be converted into the 2. That is the reason this particular vectorizer is called as count vectorizer. This particular vectorizer is called as count vectorizer because it converts your words into a vectorized format, in the vector format like this. Then worst place. So 0, 0, 1, 0, and 1. So in this way, guys, these are our reviews. These reviews are converted into the form of vector format like this. Why you're doing in this way? Why we are doing in this way? Because ultimately, when you're building a machine learning algorithm is completely mathematical technique, right? Machine learning algorithm is completely mathematical technique. When you have a mathematical technique, you cannot actually work with, or you cannot go with text format or text data like this. You cannot go with love, or we cannot apply a machine learning algorithm for this particular text data. So you should represent the particular text data in a vectorized format like this. So that is the reason we are using bag of words and you're representing a data in the text format. That is what I've done here. So first we have imported this particular count vectorizer. After importing this particular count vectorizer is nothing but bag of words. Then we have initialized your count vectorizer. Then we have transformed your corpus. After transforming your corpus has been converted to this. Now we can use this one for applying a machine learning algorithm. Okay, so we're done with this particular step. The feature engineering or text representation is done. So we have represent our text in the form of vectorized format in this. Vectorized format in this. So, any doubts here? Anyone in bag of words? This is how bag of words converts. So your reviews will be converted in this way, guys. So this is my first review. This is my second review. This is my third review, right? So it will be converted like this. So first review, second review, and third review. So all the reviews which is in the form of words will be converted into a vectorized format like this, into the form of vector like this. Understood? Clear? Any specific doubts?
No, sir.
Okay. So in this way, we are converting into vectorized format such that I can apply a ML model. So our next step is to apply a machine learning model or ML model, or you can apply a deep learning model. Okay. So I guess we can stop for now, and we can continue later. I guess so. We can stop for now. I guess so. We're done with the simple pre-processing. So once we're done, we can our next step would be applying a model, ML model. So I guess time is up. Or shall we continue? Can we continue or time is up?
Participants may write some doubts if they are having in chat box.
No doubt, sir.
Clear with practical hands-on. So what we've done here, we have taken the text, we have pre-processed our text. After pre-processing our text, we have represent our data in the form of a vectorized format. So our next step will be building a model. So I guess we can continue that later on.
Okay, sir.
Yeah. So if you have any doubts, you can ask me, or else I guess we can close. Okay. So I'm just stopping my sharing. So shall we close?
That's all from your end?
Yes, it's all from and
Okay.
further model building will be explained later on.
Okay. Okay.
Yeah.
Participants, you may write down in the chat box if you're having any doubt. Okay.
Ma'am, this lecture continue tomorrow also, ma'am. Hello.
Sorry.
This lecture continue tomorrow also, no, ma'am? After this
Yes.
session.
I think Abhishek sir, no one is having doubt from the participants.
Okay.
Okay.
Yeah.
So thank you, Abhishek sir, for the
Thank you.
wonderful session.
Yeah. Thank you.
You may share your mail ID if you can in the chat box so that if anyone is having any doubt, they may contact.
Okay. Okay. I'm just sharing my mail ID. This is my mail ID.
Okay.
You can contact me for any doubts or further any
Okay.
kind of.
Thank you, sir. Thank you very
Yeah.
much.
Perfect. So thank you guys for the cooperation and for all the support and everything. Okay. Thank you.
Thank you, sir.
Thank you.
हेलो. हाँ. ध्यान नहीं है, मैं यहाँ नीचे ही बैठी हूँ लैब में.